B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.
Is gonna butcher my name. Michele Riva. Oh, I did it right. I love your t-shirt. Open source is art, people, if there would be any doubt. I noticed that you're also a dog person.
Absolutely,
You have a dog named Linux. That's kind of telling. You love philosophy, astronomy, and mechanical watches.
I'm a nerd. That's it.
Yeah, with a very wide range of interests. That's good.
Get bored.
What you're going to, you are a senior architect at Nearform, and what you're going to talk to us about is about compiling and bundling JavaScript the painless way.
Hopefully.
Ladies, let's hear it for Michele Riva.
Okay, I always like that last bit, which is giving me, yeah, I like it. So, welcome everyone. Compiling and bundling JavaScript the painless way. I'm not scared of giving this talk in front of the lead maintainer of Babel. You know, I love it. We're friends. Remember, we are friends. Before we start, let me introduce myself really briefly. I am Michele. I work as a senior software architect at Nearform, Google Developer Expert, and Microsoft MVP. I'm also the author of Real World Next.js, which is a book that, as you might guess, talks about Next.js. And if you're interested in talking more about this, I will be around after the conference. A couple of words about Nearform. We are a professional services company specialized in React and Node.js. We are the lead maintainers for a large portion of the Node.js runtime itself and a lot of NPM packages. We're responsible for 1.2 billion monthly downloads on NPM. If you're looking for a full remote job, we are hiring, of course. But that's not why we are here. Let me talk about compiling. Why do I want to talk about compiling? It's because it's a pain. And it shouldn't be. So let's start by understanding what does compiling mean. Let's start with a bit of terminology. So by compiling, we say that compiling means to change a computer program into machine language. So that's the definition that the Cambridge Dictionary gives us. Moving to a less authoritative source, I want to give you another bit of terminology, which is transpiling. When we talk about JavaScript, we typically refer of the compilation phase, but we should say transpilation phase in that context we're going to see right now. So I couldn't find a better source, so this is all by myself. Transpiling means to translate a source code into a different language source code. We're going to see that in details. Another bit of terminology, bundling, because that's what we are talking about, to encapsulate code and resources into a single executable file. So let's first ask ourselves, why do we want to transpile code? I have 3 reasons to make it compatible with different platforms, write scripts in different languages, and adopt new language features. Let's see those 3 points in details. First one, to make it compatible with different platforms. So if we have to support Internet Explorer, is there anyone here supporting Internet Explorer? You're blessed. Awesome. So, beautiful. So if you have to support Internet Explorer, you may know that certain operators, certain syntax, it's not working. So you have to transcompile it from, for example, ES6 to ES5 or ES3. I don't know. And the same could occur on older versions of the Node.js runtime. For example, optional chaining is not working on Node 12. It's working fine on Node 14. If you're working on Node 12, please upgrade. It's out of maintenance mode, but you know the point. Second point was to write our scripts into different languages. And that might be the case for Scala, for example. I'm not advocating for this, but I can get that there are companies working with the Scala, for example, and has no really experienced JavaScript engineers and wants to write some scripts. And they can basically use Scala.js to transcompile from Scala into JavaScript. And that's also the case for a large number of languages. For example, we have F# from the .NET framework that via the Fable compiler can compile F# code into JavaScript. We have Kotlin, Gleam, ReasonML, Elm, ReScript, and many, many other programming languages. Generally speaking, all the languages that gets compiled through the LLVM framework can nowadays compile to JavaScript thanks to, let's say, LLVM supports that. That doesn't mean that all the languages using LLVM as a backend can compile to JavaScript, but they could, let's say that. So it's really easy nowadays to find new languages compiling to JavaScript in general. But when we are talking about compilation, we also said that we might want it to adopt new language features. So that's the case when we are using Babel, which is the de facto compiler for JavaScript. So that's an example, the pipeline operator, which has not landed yet, and I can't wait for it. Igalia, please, let's do that. So I'm a super fan of this operator, and if you want to use it today, you have to transcompile the source code into a JavaScript that can be understood by the runtime you're working on. Might be a browser, Node, Dino, or whatever. So that's an example. If you see the code on the left, you have a number of functions. You can concatenate them. You can chain them. But of course, if you try to feed a browser with that code, it won't understand anything, so you have to transcompile. That's an edge case, I would say, but we are quite comfortable working with Babel, for example, and that's because we are all used to React, we are all used to Vue and whatever that needs a compilation phase in order to get understood by browsers. So if you have a component, a React component, for example, and maybe using TypeScript, like that example here, you might want to transpile it from TypeScript and from a JSX into valid JavaScript code. So that's the reason why we typically want to transcompile our JavaScript code. Talking about bundling, we typically want bundling because we want a single executable file and serve it as a single JS file over the network. And that's the case, especially on browsers. And that's because back in the day when we started adopting, for example, React, Vue, and whatever, the browser didn't support ECMAScript modules. So we couldn't import remote code directly into the browser. We had to bundle it. And that's how it works. So let's say we have a little blog building React. We have the author profile, new article page, read article page. We will bundle everything together into a single executable file and serve it over the net. So that's basically the biggest reason why we want to bundle. Now that we know why we want to transpile and bundle, let's see those concepts in detail. So let's start with transpiling. We've said that we can transpile code base from a language to another, right? So let's take an example. This is ClojureScript. How many of you is comfortable with Clojure or knows Clojure? No one? Okay, cool. So it's basically a Lisp dialect for the Java virtual machine. So yeah, a lot of parentheses, I love them. The problem is that, of course, JavaScript doesn't understand, the browser doesn't understand Clojure. So if you want to write Clojure and compile it to JavaScript, this is the output you're getting. Not super beautiful, I would say. Let's try another example. ReasonML. ReasonML is a super important language. It shaped the way we write React today, for example. And that's an example. React component written in Reason, and I would say a better transpilation into JavaScript here. But from language to language, it's not the case. Sometimes we just want, as we've seen, transpile from superset into a subset, so from TypeScript to JavaScript. We already said that. And I showed you those examples because every language has its own transpiler. So JavaScript has Babel, which, again, it's not an official compiler. It's the de facto one. So if you want to compile JavaScript, that's #1 choice today. We have TypeScript with TSC, we have Fable, ClojureScript, and BuckleScript for other languages. Every single compiler you see here has its own pros and cons. So let's start, see them. Problem #1, it's transpilation time. And while Babel is incredibly fast on small applications, it can become quite slow on larger applications. That's also the case for TypeScript, for example. While Fable, ClojureScript, and ReScript are really, really fast. How is that possible? It's not that TypeScript and Babel are bad written, because that's not the case. They're awesome products. Fact is, ReScript, for example, it's built using OCaml, which is a programming language targeting native code. So, of course, it will be faster than native JavaScript. And that's the case also for Fable, which is written in in F#. So it targets the .NET virtual machine. So that's basically the reason why. And we have a second problem here, which is the output optimization. So we saw some examples. Babel, for example, can produce well-optimized output. Why I'm saying well with a star? That's because Babel has a powerful plugin system. So everyone can write a plugin, even non-experienced engineers. So if you end up using a plugin written by a non-experienced engineer, it might not be so optimized, so you have to keep that in mind. With TypeScript, it is less common to find community plugins, so it's quite optimized. You usually just use TypeScript itself. There are languages such as F# with Fable and ReScript that creates beautiful code for real. If you go see the code produced by Fable and ReScript, it's like handwritten code from an experienced engineer. I love it. And I'm sorry, ClojureScript. I don't like the output of ClojureScript. The problem is that with transcompiling, sometimes you lose the opportunity to shape the final JavaScript you're gonna get. So while with Babel and TypeScript, for example, while you're writing code, you can understand how it will get compiled. For example, with ClojureScript, with Kotlin, with Java, C++, it is not the case. So that's it. Let's focus from now on the most popular one. We've said that Babel is quite fast. It gets slower when the code base size grows, but by itself, it's quite fast. So TypeScript itself, it's slower, I would say. I made some benchmarks. I don't have real numbers right now, but I would say it's slower. And the problem is that you can notice how things are going to change when the code base size grows and the bundling time itself grows too. So let's go understanding why we need bundling, what are the options those days. So yeah, bundling in depth. I would say we have the three horsemen of bundling that are Webpack, Rollup, and Parcel. Every single bundler you see here has, again, pros and cons. Webpack, we all know that, it's damn hard. Rollup, it's easier. Parcel is by far the easiest of the three. But also Webpack, it's not only the hardest, it's also the slowest. Rollup, it's a bit slower. Parcel, it's real quick. Why should I go with Webpack knowing that? Because it's the king of configurations. And nowadays, I was telling that before joining the conference, I was that close from leaving Webpack, and then they published Module Federation. So here I am again working with Webpack, enjoying it every day, of course. And my question is it still worth it anyway? Do we have any alternative to Webpack and Rollup and Parcel? Yes, we have. And again, yesterday, I needed to find a couple of information for Snowpack. Went on the website, project is dead. So rest in pepperoni. Super sorry for that. Okay, we have better alternatives today. I don't know if these are better, but we have alternatives. We have Esbuild, SWC, Vite. We don't have Snowpack anymore. Super sorry. Okay, I'm going to try an experiment. Next slide, I'm going to show you a benchmark from Esbuild, from the official website. You have to promise you won't close your eyes until you see your next slide. There will be a comparison while bundling and transcompiling 3JS 10 times. We will be comparing Rollup, Webpack, Esbuild, etc. Are you ready? I will count up to 3. Keep your eyes open. 1, 2, 3. OK. So Esbuild has created 10 different builds of 3JS in 0.33 seconds. Parcel 2, which is the fastest, is still going, 32 seconds. Rollup and Tensor, and yeah, I didn't mention that, it also minifies the output. So Rollup and Tensor, 34 seconds, Webpack 5, 41 seconds. So while it is finishing, what is Esbuild? So Esbuild is a module bundler that basically, which is written in Golang with performance in mind while building it, and basically allows us with simple configuration to replace Webpack for most of our applications. And it's incredibly fast. And you might be thinking, okay, it is too good to be true. It might be a nightmare to configure it. It's actually not. You can select an entry. You can say, okay, please bundle it. Otherwise, you can just transcompile it. If you want to use your scripts on Node, for example, you don't need to bundle. You can just transcompile. In that case, you pass a flag, bundle, generate source maps, minify, and put everything inside that folder. So Esbuild, it's widely used those days in other bundlers. We will see that later. But there's another cool guy in town, which is called SWC. How many of you have heard of SWC? Beautiful. How many of you has heard of it because of Next.js? Beautiful again. OK. So these are the comparison between Esbuild and SWC. On the language specification for ES 2019, for example, Esbuild, you can't really notice here, but Esbuild is still a bit faster. But when it comes to ES 2020, SWC gets incredibly faster. So you might wonder, why is that important? Because language evolves, and hopefully we will find ourselves working with ES 2020 as soon as possible. So we want to know that we are choosing the fastest compiler and bundler, whatever, out there. SWC, it's written in Rust. It's now a project maintained officially by Vercel with other, of course, open source collaborators. And the configuration looks quite similar to TypeScript, actually. One nice thing about SWC is that it's written in Rust, so, I don't know, could be working in browsers thanks to WebAssembly. I don't know if there has been any experiment on that side, but I find it exciting. So the next one I want to show you, it's module bundler, and it's called Vite. Again, how many of you knows Vite? Good. How many of you knows that because of you? OK, that's cool. So Vite is not just a module bundler. It's a development server. It hot reloads modules via ECMAScript modules, requires a minimum version of Node 12. But again, it's out of maintenance mode, so I hope everyone here is working with a higher version. It's incredibly fast. We will see why. And it's a module bundler that does not bundle. That's because it's using ECMAScript modules. So remember when we said that the browser, it's not able, let's say, to run import X from whatever. Nowadays, it can do it. So Vite exploits that possibility. Under the hood, if you really want to bundle your code, it uses rollup. We already seen that. And during the local development process, it uses Esbuild to compile all the dependencies. And one thing that is really, really nice about Vite is that it has a 0.1 time complexity for compilation. That means that if we have 1,000 components, for example, and we change just one of those, you don't have to rebuild all the components just like you do in Webpack. You will only rebuild the one that has changed. So when developing very large code bases, this is a game changer. And OK, I've already talked about that, but this is the example, OK? So it's using ECMAScript modules on the left instead of CommonJS to run it on the browser. So that was Vite. And as I said, I wanted to show you Snowpack because I found it really interesting. But yesterday, I've prepared this talk before the 20th of April. Yesterday, I said, OK, I need a couple of information about Snowpack, which version is it? I went to the website and saw that. Not good, but I'm going to show you anyway because it shares many things that we nowadays can find inside both Vite and Webpack. So you will always see Snowpack with a resting pepperoni right under. It's really similar to Vite. It's a module bundler that doesn't bundle. has a O1 time complexity for compiling dependencies, again, super useful, and builds all the dependencies only once and cache them until they change. Uses Esbuild, again, under the hood. And if you want to do a production build, you have to use either Webpack or Rollup. Webpack, it's recommended on their official documentation, but okay. It was built from the Skypack CDN. Okay, I can't click on run on the screen. Super. Oh, maybe I can. Oh yeah, it's working. So basically, the idea was to, import that directly into the browser, so you can actually run the code you just imported directly into the browser without passing from Node.js, which is quite dope, actually, and reminds me a lot of module federation in Webpack 5. That's why I wanted to show that anyway. So if you go here, for example, and see what the import looks like, it's basically an export all from a dependency. So really cool. Super sorry to say that the project is no longer maintained, but I guess it shaped a lot the way we use Vite Webpack those days. In fact, in the official documentation, it states that you should use Vite instead because they share many similarities. And to show you that, with Webpack, Rollup, and Parcel, if we add more dependencies, the build time and the compile time will grow linearly, while with both Snowpack and Vite, it will remain the same. That said, thanks to Vite and Snowpack, I'd like to say that the future is no bundle. So maybe, because at the beginning, we said that the reason why we started using bundling was because we basically couldn't have imports directly into the browsers. But nowadays we can. And as shown here, no one is working on Explorer anymore, I hope. So the future is bright. And there's also good news, because the Vercel team has hired the guy who created SWC, and nowadays he's working on a porting of TSC to Golang, which is the last pain point I personally have in my daily routine. I start working on TypeScript, code base grows, and I have to wait forever for type checking. So I'm really looking forward to this. And I guess that was all for me. Thank you all. You can find my information here. Thank you.
Thank you, Michele.
B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.